All right, so this is exercise 2 on the displaying data with graphs sheet. The answer here. Okay, so we graphed it. Is it a straight line? Perfectly straight?
Pretty close.
Not perfect though, right? Does your scientific intuition tell you that it's a linear relationship though?
Yes.
Why? Well, it's pretty straight, right? And what are we doing here? Aren't we like, we're measuring the mass of a substance and then doubling it and then measuring the mass. Like it sort of feels like the more you have, if you got twice as much, it should weigh twice as much. Like you sort of get that intuition. It should be a straight kind of thing. So let's just draw a line here, right? Should 0, 0 be a data point? If you got none of it, it should weigh none. It's pretty straight. Okay, describe the resulting curve. It's pretty straight. All right, use the graph to write an equation relating the volume to mass of alcohol. Anybody come up with an equation? Hard, right? Okay, here are the steps. Number 1, find the slope. Find the slope. Pick 2 points that you think are good indicators of the line. Now you could go 0, 0. Yeah. And now I did not do this very accurately, right? So of the 1, 2, 3, 4, 5 data points, which 2 do you think are closest to the line? Well, not the first one. Is that one pretty good? The 20 one's pretty good. That one's pretty good. That one, I'm going to go with those 2 because they are the closest to the line. Your graph might look different. Will you get a little slightly different value for slope than me? Could be. Is that okay? Absolutely. It's the process amount. Okay? It's the process amount. So let's find the slope using those 2 data points. The slope is rise over run. y2 minus y1 all over x2 minus x1. Remember this? Nod and say, oh yeah, I remember that. Perfect. Okay, so my y2 is this value here, right? Now should I read it off the graph or should I probably just go with the number up there? Number up there. So that's the 31, so it's 23.7 minus this one here, which is the 15.8. And then the x's are 30 and 20. There's mass scattering as people grab their calculators. I can do the bottom on my head. What's the top?
7.9.
I hope you can divide 7.9 divided by 10 in your head, and you should get 0.79. Now again, if you got something between, say, I don't know, maybe 0.65 and about 0.9, you're probably pretty good. As long as I see that you've done the process correctly, the numbers really don't matter to me. Now, that's only one part. Remember, if we want an equation, I need y equals mx plus b. Which one do I have here? I have the m. How do I get the b? Which is right down here. Now, it should be at 0, right? It should be at 0. How close to 0 is it? Let's just check this. I'm going to show you the step here. Because if it doesn't go through 0, you're going to have to be able to handle that. So I need to show you the steps. Okay. So to find the y-intercept, we're going to write y equals mx plus b. What might have happened here? Let me just back up a little bit. What could I have done to this experiment that would have made the y-intercept not 0, 0? Keeping in mind that I'm measuring the mass of alcohol. I'm taking a liquid alcohol, I'm pouring it into a graduated cylinder. It's already finished high school. Thank you, Riley. Okay? And I'm weighing it. Would I get a y-intercept of 0? The cylinder could weigh, it has to weigh something. It's glass, right? Okay, so that might have been the case here. Maybe this person, maybe the cylinder weighed 5 grams, and the person has automatically subtracted it, and that's why you came up with 0 here. Okay? How are you going to deal with it if it's not done that way? Okay, so let's investigate that a little bit here. So I got y equals mx plus b. Now, what do the y and the x represent? X and y, exactly. Which x and y? This one? This one? This one? This one? This one? This one? All of them, exactly, Hannah. In fact, all of them, and even ones that are like off the chart. Off the chart. Okay, so I'm going to leave y and x. They're not constants. They are variables. I'm going to write y equals m is 0.79x, and I'm going to write plus b. I still got to get my b. Now, can y and x be equal to something? Yes, they can. Let's pick a number. I like this one because it's right on the line. The x is 20, so I put, well, and y for the 20 was my, what's that number? I have to scroll up. What is it? 15.8. What is it? 15.8? Okay, so the corresponding y here is 15.8. So 15.8 is equal to 0.79. The corresponding x to that is the 20 plus b. And now I have an equation with how many unknowns? Just one. Can we solve that? Absolutely. Go ahead. What should the number be close to? Go ahead, solve it. 15.8? I think you're right. So I didn't just look at it on the graph. I actually did the math, and I apologize for my chicken scratch here. I learned how to write in Australia, so everything is upside down. It's true, I did learn how to write in Australia. Oh, I go the other way. Right? So anyways, you get b is equal to 0. Yeah? Makes sense? Nod and give me the yeah. I more or less get that.
Yeah, I more or less get
More, yeah? Okay. If you don't get it all, then give me the... What is he talking about? Because guess what I'm going to get you to do now? Oh, hang on. Actually, we didn't finish number 3, did we? We didn't, because it said... So we've got our equation. So what would our equation be? Our equation would be, and I'm really low down. Our equation then would be y equals m 0.79x. Do I need to write plus 0? Not really. Could I replace y and x with anything?
Yeah.
What is the y quantity here, Keelan? On the graph.
Y 15.8.
The y quantity is the mass, right? Yeah. So I could write m for mass is equal to 0.79. What's the x? In the volume?
Yeah.
Right. So I could write m equals 0.79 v. I could. There are some of you that are not going to like this, right? Does it have to be this way? Does it have to be this way? I'm okay with either. Okay? There's not always a 100% correct answer. You're going to have to get used to that. What is the name given to this quantity? In other words, what does the slope mean? How did you come up with that, Hannah? What are the units? The y is in grams. The x is in cubic centimeters. The quantities are mass over volume. What do we measure? What's mass over volume? Density. The density of this particular alcohol is what? 0.79 grams per cubic centimeter. Yeah? All right. Have you done the graph yet?
Yeah.
Okay. Have you described the relationship between force and acceleration? Like, have you said it's linear, or it's quadratic, or it's inverse? Part B, you are to describe in words the relationship. You have 3 choices: linear, quadratic, or inverse. Have you written the equation? I'm guessing no. And have you found the units of the slope of the graph? I'm guessing no. Go ahead and do C and D. I'll give you like 5 minutes.
No, it's got acceleration now.
No, yeah,
It's velocity. It's velocity.
How do you know?
I searched it up.
Cheater.
I'm not a cheater. You're doing some stuff. No, I switched stuff like you. What was the first answer? What did you say? I think it's velocity. I think it's velocity. You can never demonstrate this speed.
All right. So let's graph it, I guess, right? Do you have to go by the same amount across the bottom as you do up the side? No, you don't. 5 and 4.9, 10 and 9.8, 15 and 15.2, 20 and 20.1, 25 and 25. This one is like, is it straight? In fact, it's almost ridiculously straight, right? In fact, I think it's straighter than the last one. Does it go through 0, 0? Should it go through 0, 0? I guess I should read this. That's maybe a good idea. The instructor placed a 1 kilogram mass on a horizontal table that was nearly frictionless. The instructor then applied various horizontal forces to the mass, in other words, push, and measured the rate at which the mass gained speed or the acceleration for each force applied. The result of the experiment is shown on the table. So there's this like air hockey puck on a table, right? Gives it a little push, measures the acceleration. Gives it a bigger push, measures the acceleration. Gives it an even bigger push, measures the acceleration. The results are shown. Plot the values. Okay, I did. Draw a curve, the best fits all points. Is it going to be going through 0, 0?
Yeah.
If you don't push, it doesn't accelerate. Describe in words the relationship. It's linear. I sort of gave it away because I asked you for the equation, and unless any of you in here know calculus, you're not going to come up with the equation without knowing calculus, so it's going to have to be a line. Okay? Write the equation relating the force and acceleration of results in the graph. I guess I really should have drawn a line here. Nope. That's the one I want. Okay. What's the slope?
0.98.
It's pretty close to 1, isn't it? Do I need to go through the calculations? Did everybody get about 0.98? Yeah? Close enough? Somewhere between 0.9 and 1.1? What'd you get?
Oh, wait, 1.1 there, again.
Yeah. Almost in between. Okay. So, I mean, this slope is really, it's almost 1, isn't it? Right? Ryan said 0.98, we'll go with that. What'd you get for a y-intercept, Ryan?
What's the y?
What did you get for? I mean, it's close to 0, isn't it, right? Yeah, you got 0.5.
Yeah.
Okay. Is 0.5 close enough to 0 here?
Yep. Yeah. No, you don't have to. That's what I got. So it doesn't work for the first two numbers, but the formula works for the rest of them.
Okay. Science isn't perfect, is it? Right? There's always going to be some uncertainty. Should we have a discussion about significant figures?
Oh, no. 6-day rule. Wait, what? Oh, we should probably do that as well.
Yeah.